I was learning and experimenting on Splunk Enterprise platform, I found two problems. First, the cost. While Splunk gives us deep analysis based on its logs, its volume-indexed billing model triggers massive, unpredictable pricing spikes. During a system anomaly, a microservices, if it unleashes a redundant streams of debug logs or error logs, because Splunk's log observers connect queries data that is already indexed inside core Splunk. So you have to pay full volume premiums at the indexing edge before any contextual filtering or sampling can be applied. The second is security. Connecting autonomous AI agents via the MCP introduces unmitigated threat vectors. Because MCP vectors hold privileged credentials, COSI nodes that are highly vulnerable to indirect prompt injections via malicious payload and sensitive data exposure and privilege design failures. While tools like Splunk MCP TA provide reactive logging, they cannot block these malicious tool calls in real time. That is why I built AegisOps. AegisOps applies dynamic contextual sampling and data minimization at the ingestion edge to reduce the volume-based bill spikes before they hit your indexer. Simultaneously, it acts as an active firewall for your MCP ecosystem. So it intercepts and sanitizes and verifies agent actions in real time rather than just monitoring the blast radius. Now I'm going to simulate a real-world production incident. So in the terminal, I'm pushing a broken container image to a live payment service. Let's watch what happens when a deployment goes wrong. Almost instantly, the Prometheus Alert Manager detects the crashing pods. It fires a real-time webhook directly into AegisOps. So the LangGraph agent wakes up and entirely on its own begins investigating the cluster state and pulling the high-frequency error logs. So it is using the Splunk MCP tool to query the logs. Here is where AegisOps shines. It realizes these crashing pods are generating massive amounts of log noise that will spike our Splunk ingestion bill. Autonomously, it generates an open telemetry filter config, connects to the Kubernetes API and deploys it. It stops the compounding telemetry costs dead in their tracks before a human ever opens their laptop. Next, the agent decides the best fix is to roll back the broken image, but because mutating a production cluster is highly sensitive, our semantic firewall kicks in. It intercepts the LLM's tool call, pauses the execution graph, and escalates to a human. Over here in Slack, the on-call engineer receives the exact root cause analysis and the proposed rollback command. The agent cannot proceed without any explicit approval. So here I'll click approve. Because we are using ngrok, the button click traverses the internet and resumes the local LangGraph state. The agent instantly executes the rollback. Our pods are recovering, so the incident is resolved and our telemetry bill is also safe.